All right, so once we get the CCW software open, you'll have this start page showing. And like I had said in the video I posted, there is some built-in help, some training videos and stuff. So you can, take a look at that over here under getting started. We're going to do a new project basically. And then if you had any recents, you can kind of come and find them here pretty quickly. You can also go to File and Open. So, this is all like a standard looking Windows thing, right? So all that is exactly what you're used to in other software packages. But we'll hit New here. We could also do it up there at File. And the path, this is just the default folder that it picks. It's like My Documents and CCW, and I got all this, stuff in the front, but you'll probably have a little bit smaller path there, but usually the My Documents and the CCW folder. The project name is default. It just picks project, and then it'll probably put 1 since you guys it'll be the first project for you. I'm going to call it micro test, just trying to be something unique and different, hopefully. And we hit create. And when you do that, it'll take a moment. It's just going to kind of start to build the structure of the project. So we call it a project file. The project file could just be this one micro PLC, Micro800 PLC, or I can also add additional devices into the same project. So it doesn't have to be just this one controller. It could also be a panel view touchscreen or a drive and other devices. But we're going to use controllers because we're using the Micro800 controller. And I have several family members of the Micro800 family, the 810, 20, 30, 50, and 70. We have the 820. So we're going to pick the Micro820. And then there's 3 part numbers here. We're going to pick this last one because this matches the one that, the demo unit that you guys have. So the QWB. And we're going to leave the version default at 12. This is just giving you information about what this controller is. You get a little picture of what it looks like. So it kind of matches what you have on the little DIN rail that you got today. And then you're going to hit select, and that'll put it here. And then we'll say add the project. And this will take a moment. Not really always good for doing live demonstrations. So so when you first come in, you're going to have just this Micro820 kind of thing in the middle. This is basically all the properties of the Micro820 itself. And there are some properties down here. There's general, memory, startup, serial port, Ethernet, and stuff. The only thing I need you to really be careful of here and be sure to remember to do is to come to the, anytime you create a new project, come to this Ethernet option and make sure that you have typed in the IP address here. Because right now, by default, it's set to obtain IP address automatically using DHCP. So if we didn't change that, when you downloaded this program to this controller, it's going to overwrite the IP address that's currently in there. And the ability to get back into the controller is going to be very hard for you. This class will go from basic PLC to very, very advanced PLC very quickly, because that'll take some effort to figure out what you did. So what you want to make sure we do is, again, the very first time, and every time you create a project, but the very first time you do it, configure the IP address. And everybody's PLC has been set to the same, so that way I can make it easy to communicate to everybody. And it was 10.10.1.11. All right. So even though the PLC has the address inside of it, you still got to type it here, because when you download it, whatever is in this box is going to overwrite what's in the controller that you have currently. The subnet mask will kind of auto-populate. You can go ahead and leave it as is. This is perfectly fine. The 255.0.0.0. So, but this first one, IP address, is very important. So you can see there's a a number and then a dot and a number and a dot and a number and a dot. So if you're not familiar with IP addresses, they're set up as these 4 digits with the dots between them. The valid ranges are 0 to 255. So for each one of these digits. So I picked 10.10.1.11 purely just out of randomness, but it could be anywhere from any number between 0 and 255 in these boxes. And if you watch the video on how to change your IP address, we discussed that whatever you set your computer to, this last digit has to be unique. So you can't make your laptop .11 as well. You'd have two devices on the same network with the same IP address, and they're not going to communicate to each other. That's what we call an IP conflict. So that's about it. Everything else we don't need to touch. Don't need to worry about interrupts or any of this other stuff. Just leave it alone. If you can click through and look at all the options, that's no big deal, but you don't need to change anything from default. So that's it as far as configuration goes. Now, in the video I showed, and again, I won't be able to really demonstrate this live, but when I click the connect button, it would actually, it's going to pull up another window that will basically allow you to kind of browse the network. Now, you will only have one thing, right, tied to your computer. You'll have your Cat5 cable going between your computer and the PLC. So those are the only two things that are on that network, is your computer and that PLC. So you should only see one thing. I'm seeing a bunch of stuff currently because this is actually, I'm tied to the Doug Otto network, and these things are actually on the network apparently. So I can see a bunch of panel views out there currently, but you will only see one thing. So what's going to happen is when you try to connect, you'll get this, then you can click and you highlight the item you want to connect to, which again will be the Micro800 that is, should only be the one device. Highlight it blue and then hit OK. And then that will set this this path to that device. And then that way, when you hit connect again, it'll connect right to the controller. You don't have to set that path again. When you do hit connect for the first time, it's going to ask you to download, because whatever is here on my computer does not match what is actually in the controller right now. So it's going to say, hey, do you want to download? And you'll say yes. Just remember the terminology here from in the PLC world. We use the term download when we want to copy the program from our laptop and download it to the controller. And we use the term upload when we want to take it out of the controller and upload it to the laptop. So just remember that, because if you chose upload out of the controller, well, then whatever's in the controller is going to overwrite what you've been working on. So if you've made a lot of edits to your program and you accidentally hit upload, whatever was currently in the controller is going to overwrite everything you just did. Same being true for the download. Usually you're downloading, it's perfectly fine, but if there's a known good program in the controller and you're not quite sure if the one on your laptop is the valid one or not, then if you download to it, then you're going to overwrite what's in there. So always be careful of what you're doing, but typically we'll do a download. Nothing wrong with uploading. There's a lot of times you'll do that. You might not have the program, so you can easily upload the program out of the controller and look at it and edit it and re-download it again. So that's the real good reason for uploading out of it. So once you, so the first thing I'll have you do kind of over the weekend, or when you get your software installed and I know you got get your adapter and whatnot. So the kind of the first task will just to be, get the software installed and open and just make a program like this or project and just simply get connected to your controller. If you can do that, then, that's great. You've made a major breakthrough. it's not that difficult, but of course it takes, first time doing it, there's always, a little bit of a learning curve there. So that would be kind of my, your main goal, at least, between now and perhaps Monday, just see if you have some, be able to do that. If you can't get the software installed, just let me know. We'll do a workaround. Like I was mentioning earlier, I got a couple workarounds we could probably do. Some cloud-based virtual machines. Now, once you do have that breakthrough done and you're able to connect and just download to the controller and make that connection to it, what we'll really start doing from here on out is programming it, of course, right? So getting connected to it, that's just half the battle. What we got to really do is write a program. So if we go to programs, right now there's no programs actually in the controller. So we actually have to right click here and we're going to say add. And we have three options. There are basically three programming languages that we can use here in this controller. We can use ST for structured text, LD for ladder diagram, and FBD for function block diagram. We're going to stick with ladder diagram throughout most of this class. Structured text looks more like a, it's very reminiscent to like a C++ or Java scripting. So it's a little more, looks a little more like a traditional programming language, shall we say, which is good, but some people prefer coding in that. But it's kind of bad because you can't really, to troubleshoot the code, it's not quite as intuitive as the ladder diagram is. So it's a little more complicated. So structured text is usually used when you have like very complicated mathematical type things you want to do, because it's easier to write equations out in that kind of Visual Basic C++ looking type of programming. To do complex equations in ladder logic is definitely hard to do. Function block is another programming language that is really popular in the process space, and it kind of allows to show like the flow of the logic. So instead of it being a ladder structure, it's more of like, you put the function blocks on like this big kind of page. It almost looks like a drawing in a way, and you kind of just link the function blocks together. So like, the output of this function block will flow into the input of this function block, and the output of that function block will flow into the input of this other block. So you can kind of follow the flow of the logic. So it's very popular in the process space, which of course we have lots of around here. So function blocks are a pretty popular programming language. We maybe will touch it. Typically we have not touched function block diagrams. This class is always kind of meant to be pretty basic intro to PLC. So we'll stick with ladder logic, as ladder logic will be easy to program and easy to look at and troubleshoot. So after all that, we need to make sure we just choose, when we say program and add, we want to make sure we choose a ladder diagram program. It's going to call it PROG1 by default. You can of course rename that to whatever you want. If I double click, it's just going to open it. I should right click and rename it. It doesn't really matter. You don't have to rename. You don't necessarily have to rename them, but as you kind of become, a little more savvy at programming, you might want to give these programs names because they're going to be more intuitive, right? So you could have one program running like, shall we say pump 1. You can have a second program running pump 2. So you would want to call each program, pump 1, pump 2. That way, the logic for pump 1 is in that program called pump 1, right? So you just kind of keep your code and everything organized so you can create multiple programs like that. This first program will be the one that is like what we'll call the main, which means that this is the one that always gets executed first, and then it would do the other ones after that. So in the ladder diagram, we have rungs, and each rung it was, again, if we call it a ladder because it kind of looks like a ladder when we do this. We have the rails. So this line here is a rail. This line here is a rail. So kind of think of the rails of a ladder, and then the rungs of the ladder would go across right between the rails. So the way how the PLC executes the logic is, it comes to program main. It comes in here, and here's ladder. Here's rungs 1. So it executes rung 1 first, and it starts from left to right. So it kind of executes left to right. And then when it's done with rung 1, it'll go down to rung 2 and execute left to right, rung 3, left to right. And the PLC program can have numerous rungs. It could be, they could be small. It doesn't have to be, but 1 or 2 rungs, or it could be hundreds of rungs in this program. So regardless, it's going to always start at rung 1 and go down, go across, down, across, down, across, down. And it takes a certain amount of time to do that, right? So there's an execution time. So the more rungs you have, the more logic it has to move across. Obviously it's going to take a little more time to do all that. So that's what we call the scan rate. And if you remember, we're talking about some of the introduction to PLC stuff. We talked about the scan where, the PLC basically does this sweep. It just does a continuous sweep where it reads the inputs, solves the logic, writes the outputs, and does it over and over again. So this is the solving the logic part when it comes to rung 1, 2, 3, 4, 5, and going across. That basically will be solving the logic. So reading the inputs, doing all this, jumping to the other programs you have. If you have multiple programs, right, you got to do main, all that, then go to, program 2, all that, program 3, all that. And then when it does all that, that's one sweep, and it does it all over again. So it still does it very fast, still in the order of milliseconds, but the larger the program, then obviously the slower the scan rate will be. Now, so we spent some video time, in that module talking about the discrete inputs, discrete output devices, analog input devices, analog output devices. So the reason for all that was because, those are the things that are going to get tied and wired to the PLC. And when they come into the PLC as inputs, then we're going to use them in here to, to scan them and do some logic control on it. So a very simple example. Let's just say that, we have 2 inputs into our PLC and we have 1 output. And the 2 inputs in the PLC are going to be a start push button and a stop push button. And our output will be a contactor that will basically turn on a motor. Okay, so when I press the start button, we want to turn on the motor. When I press the stop button, we want to stop the motor, right? So the way how we would do that is we would actually have to wire the start push button to the PLC, right? It'll go into the first input, and we would wire the stop push button into the PLC. That would go to the second input, and we would wire the contactor, the thing that will turn the motor on, from the output. So that would be like our first output. Now, this is where every PLC is going to be slightly different. The ladder logic is pretty much universal, but where every PLC pretty much differentiates themselves from each other is that addressing, shall we say, in the PLC. Like, what is the address, or what is the tag that we use to reference that input that got wired into the PLC? So in the Micro820, we're going to go to what's called the global variables. And when we come to global variables, it'll open up here in a moment. We get another tab, and you see in the software here we have all the tabs up top, so we can jump back to the main. We can jump back to that Micro820. We can even jump back to the start page, and we can close these things if we want to as well. So you can have multiple things open. When you come to global variables, we're going to see these. There's already a bunch of tags. These are called tags, This is basically internal variables, or variables that are inside the controller that we can use in our program, but commonly known as tags in the controllers. So they already have some tags created. I didn't even do anything. I never created these tags. So these that have the IO in front of them, well, these are our actual IO points. These are the terminals. You know, on the PLC itself, there's a row of green, and there's, you know, at the top, and a row of green terminals at the bottom. Those are where the inputs and outputs are actually wired to. So we start, and the way how we decipher this is we have IO, which stand for input output. The EM stands for embedded, because we call that an embedded IO, but it's embedded in the controller. The green, the green terminals at the top and the green terminals at the bottom, they're fixed. Therefore they're embedded in the controller. And then DO stands for discrete output, and 00 is basically the number. So I said earlier, input 1, output 1. So technically, in the PLC's eyes, that would be known as 0. So the very first input is addressed as 0. So so we have DO00, DO01, 2, 3, 4, 5, and 6. So that'd be basically inputs 1. Yeah, so again, this is where it gets a little confusing, but that's our first input, second, third, fourth, fifth, sixth, and seventh output. I said input, but output. So the very first output that's get wired, it's referenced as 0, but it's, you know, technically it is the first. We don't say the 0th input, so we say the first input or output, but it's referenced as 0. So just kind of start to think like that. So 00 is our very first output. And then down here we have the IO, the EM, the DI, which would stand for discrete input, and 00. And therefore we have 00, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have up to 11, right? So we know that the 0 sits, so to 11, that's basically 12 inputs that we have on this controller. And we have a couple of analog points. So these AIs would stand for analog input, and the AO stands for analog output. We're not going to worry about these guys quite yet. And then at the bottom, we have all these SYS, VA. So these are what we call system variables. So these are like internal tags that would refer to things in the controller system itself. So we can reference these tags if we had to. A lot of times they could be just, you know, diagnostic tags a little bit, but we call them system variables. So usually they're used for, you know, either troubleshooting or trying to determine something, what the status of the system is. We typically, you know, so we're not going to really worry about these system variables too much, but they do exist. Now at the bottom, I have the ability to create new, so I can create a new tag and use it in the program. And we'll get there as we move through the class a little bit. But right now, let's just worry about these embedded IO device points. The other thing to note is here in the global variables is this number here. This is confusing, right? And it's not intuitive to you, right? Necessarily, it's definitely not intuitive to an operator who doesn't know how to program, right? So what we want to do is we want to give it an alias. We want to call it more in line with what it really is. So like, for instance, I said earlier that the first input was going to be the start push button, and the second input was going to be the stop push button. So I can actually call it that. I can call this start. I'll just do PB for short, and I can call this stop. Let me try to put a space here, see if it likes that. It may not like a space. Oh, it took it. So I can go back and double click here and change that, right? So now DI00 is going to be, it kind of has a nickname now, as start push button and stop push button. So this will really help you in your programming by basically typing these aliases in based on the inputs, right? So if we say, hey, you know, so when I give you some programming assignments, I'll say, okay, what's, you know, use 00 as your start, use 03 as your emergency stop or something. So you can name them based on kind of what you've been told there, and it'll make it a lot easier to kind of figure this out. And then the last thing we're going to do is the output was going to be the motor, right? So we'll just call this motor. Now, in this example that we're doing, I'm only using 2 inputs and 1 output, but I have 7 outputs available, and I had 12 inputs available. So it's perfectly fine. I don't have to use them. I'm just not going to wire them. They're just going to sit there as kind of idle or spare points. So I don't have to name all these things. I only have to name what I want to use. It's also, you don't have to use 00 for the motor output. You could stick it to any one of these 6 other ones. Usually it's logical to use the first one, right? It's logical to use the first input and output, or the first input and the second input, but you could easily put the motor on 3, and you could put the start push button on 4. So it doesn't matter as long as you know where it's wired. And then that way you know how to reference it in the program. All right. And there's nothing to do with these ones not being used. There's no turning them off. They'll just sit there, and they won't be wired, so they won't do anything. And you're not going to reference them in the program anyway. So even if you did have something wired to 2, if you didn't program in the PLC, then it's never going to really matter. All right, so we got our aliases created. We've got our kind of our inputs and outputs defined. So now we would come back to this main program, and now we're kind of ready to actually write a program to turn on that motor. So the premise was, when we press the start push button, we're going to turn on the motor. So we would consider that as a simple series circuit, right? So start thinking now in terms of like electricity flowing. Even though it's a program and it's digital, if we had hardwired this push button to a motor, just like a light switch, right? When you turn on the light switch in your house, electricity will flow through that switch and goes through a wire and goes up to the light and turns the light on. When you turn off the switch, well, the switch opens and it breaks electricity to the light, and therefore the light doesn't go on anymore. So that's kind of exactly what we got going on here with this motor. So I have a few items here to work with as far as the programming. Now there are lots of other functions here, but these are the most basic ones that are kind of showing right here on this little menu bar. And basically we have what's known as a normally open contact. They call it a direct contact, or examine if closed. We have a normally closed contact, which is a reverse contact, or an examine if open. And then we have a reverse coil and a direct coil. So for our inputs, we're going to use these contacts. For our outputs, we're going to use these coils. All right, so start push button, we'll treat that as a direct contact, examine if closed, basically a normally open contact. So I'm going to just take this, and I'm going to, what I did was I used my mouse button, and I clicked it, held it down, and I'm doing a left click too, by the way, and I just drag it down to that rung 1. This now pulls open the variable selector, and we have several tabs here: global, local, system, and then IO. So I want to go to IO because this is again, we're tying this to real IO from the field that got wired to the PLC. So I'm going to use, since I gave my aliases to them, I'm going to go down here and highlight this one, DI00, start push button, and I'm going to hit OK. And now that has now taken this contact and addressed it to that point in the PLC, so that now if this was a real system and I had a start push button wired to it, when I press that start push button, this contact will change state. It'll actually now become a 1, and it will pass power, so to speak, through the switch. And when I took my finger off the push button, it would open. So, and then just like the light switch, when I turn the light switch off, this would open and there would be no quote unquote electricity or no flow through this contact to get to the next point of the logic. All right. So let's just start with the real simple. When I press the start push button, I turn on the motor. So the motor is an output. So I'm going to take a coil, and we're going to use direct coils. Basically just means that it'll energize. When I turn it on, it energizes. And we do the same thing. We need to come to the IO tab. And since it's an output, it's a DO. And we're going to use our motor. So it's DO00. So I'm going to highlight that. I'm going to say OK. And that's basically the program. So I press the start button and I start the motor. And I turn off the start push button, the motor drops out. Right. So if I was happy with this, then I would come back to my, I could come back here to my Micro800 and I can hit connect. Or I could also go up here to disconnect, this button up here. I can see it says it click to connect. So I can hit that button right there and I can connect. And when I connect to the controller, it will say, do you want to download? And when I download, it will now download this program and this logic to the controller. The settings that I said earlier, the IP address, they will also get downloaded. So if I change this, that would also, get re-downloaded. So best to not come back and change that once you actually do set that. But any changes here would also get downloaded. But basically, this was what I changed since the last download was this program. So this would really be what gets downloaded. All right. Now, we had said, this little programming example, just to kind of let you think about how the programming goes about, is that when I press the start button, it starts the motor, but when I press the stop button, it stops the motor. So in the light switch example, when I turn the light switch on, well, the light switch stays on, right? You don't have to sit there and hold the light switch, right, in your room. So you walk into your room, you flick the light switch on, you go, sit on the sofa or sit on a chair, right, whatever, and then the light stays on. And then when you want to leave the room, you get up, you walk out, you flick the light switch off, and the light goes out, right? So we call that a maintained switch or a maintained contact, right? Because you switch it on and it stays on. It does not turn off. Matter of fact, it will never turn off if you don't do it yourself, right? So in the industrial world, we typically don't use maintained. We use what's called a momentary push button. Momentary push button means that it'll only stay closed when I'm pressing it. It's basically spring loaded. So when I put my finger on the push button, it'll close. But when I take my finger off the push button, it'll spring back open again. And we like that in the industrial world because that gives us a little bit of a safety aspect to it. Because, if there was some kind of issue and the motor got shut down for some reason, well, if that start push button was being held in, well, it's going to start the motor back up again. And you might think that, well, that's a good thing, but it may not, because maybe someone's working on it. Maybe there's a person around it. So it could be a potential safety hazard. So typically we like to use momentary push buttons. So we have a little bit of a flaw here, right? Because if it's a momentary push button, when I'm pressing the button, the motor is on, but when I take my finger off the button, the motor will stop. So that's not good because I don't want to stand here all day and hold the button down to make that motor run, right? We want to be able to press it, walk away until I come back and press the stop button. So we have to build pretty much one of the most common building blocks in the programming, ladder logic programming, is we might have to build a latch circuit. And a latch circuit is basically when I press the start push button, it's going to start the motor, but then I'm going to use a contact that's off this motor to actually latch it in, right? That way, when I take my finger off the push button, it's basically using its own contact to hold it up, hold it in. So even though this is a coil, I can also reference this very exact same device as a contact in the program. So if I were to add a branch here, I can actually add a branch, and I can create what's called a parallel circuit. So now I can put a contact here, and it wants me to address the contact. So I'm going to pick the output. So now I have a parallel path, right? So parallel means it. So if you're thinking about digital logic, this is an OR, right? So if this is true, then I move on to the motor. So when I press the push button, that becomes true. This gets energized. When this gets energized, this now becomes true, and we'll energize that. So when I take my finger off the push button, this stays energized because it's holding its own self in. We call that a latch circuit, right? You kind of follow that. So press the push button, energizes the relay, the output here. I'm using a contact off of it. So when this changes state to a 1, this becomes a 1 or true. And when this becomes true, then my parallel path will continue to keep this motor true. All right, simple latch circuit. You'll see this hardwired for real on relay logic. You'll see it programmed in the PLC as well. So the last piece of this is, how do we actually now turn off the motor? Because the way how this is now, this is never going to turn off ever, right? If I press the start button, it energizes this motor, then the motor contact itself is holding the motor in. There's no way to ever turn this off. So the last piece of this is to put that stop push button into this rung. So what we're going to actually use for the stop push button is we're going to use the normally closed contact now. So I'm going to take this normally closed or this reverse contact, and I'm going to put it right here, and I'm going to link it to the stop push button. All right, so now you can see where it went. So I want it to be a normally closed, because remember, this is now, if this and this, this turns on. So if the stop push button is not being pressed, then there'll never be a flow, right? It'll never be true. So we're going to use the opposite state. All right. So if the normal state is the push button's off because I'm not pressing it, then the opposite state is a 1. So basically, when I'm not pressing the push button, this will be true, or a 1. And when I do press the stop push button, then it's going to be the opposite, right? So when I do press the push button in the physical world, it becomes on, but in this virtual, it'll become off because I'm going to use the opposite of it. All right. So, and that the reason why we need that is because, again, when I press the start push button, I don't have a problem here. This is normally closed, so it's true. So that means I'm going to pass power, or I'm going to, it's going to go on through. They call it examine on, examine off terminology as well. So when it's off, it'll examine, it'll let you flow through here. and it's going to energize the motor. When I energize the motor, it will now turn on this contact, and that also will come through this push button to the motor. So to break the latch, by pressing the stop push button, then this now opens. And when this opens, well, that'll drop this motor out, right? Because it breaks the path, breaks the circuit to the motor. And then it cannot start again until I press the start push button. So that's why, again, that's kind of like why we do that. It's a little bit of a safety factor, but we can't start the motor again until I physically press the start push button. So that's a real basic example of a ladder diagram. So we're just kind of, just somewhat throwing that at you for the first time. I know but this will be kind of the, this is the type of program we'll be doing. You'll be looking at these discrete devices and then kind of making, logic around those conditions, right? So we'll say, hey, these are the conditions for whatever to turn on. These are the conditions for whatever to turn off. Then, can you program, those conditions, based on this kind of ladder, of ands and ors, basically. So two things in series will be an and two things in parallel will be an or, right? Because, it's this and this equals that. And it's like this or this, right? So that's, think about ands and ors, that terminology for this programming. So at this point, if I was able to, I could download it. And what I can't demonstrate right now, unfortunately, and I'll try to make a video of it so you can see it working in reality, is that when I am actually connected to the controller and I have the program in there, it will actually show me, it'll highlight in color what contacts are actually, shall we say, on or passing power. So for instance, this would be highlighted green right now if I was connected, because it would be normally closed contact, it would be passing power. When I press the start push button, it would highlight green because it got turned on. When this energized, it would highlight green because it's turned on. And of course, when this got turned on, then this would be green as well. All right. So, so that will kind of be your first programming assignment, is to kind of basically mimic something just like this, just to get it, programmed, downloaded in the controller, and then just watch how it behaves by pressing the, pressing the buttons. Now you say, well, I don't have real push buttons. So you have the ability to, you'll have the ability to kind of force these things on to watch them go. So I'll show you that step as well. And once I can get connected, so I'll probably have that in the video. So you can actually create logic. You can kind of force the inputs on just to test them, and then watch how the logic works, and then force them off again to watch how it works. Any questions on this? This is kind of what I wanted to cover tonight. So we're going to kind of wrap it up here as far as me talking. But any questions on kind of this concept, or this looks kind of straightforward, or still a little cloudy? If it doesn't quite connect yet, don't worry, it will. But just wanted to take some time to show you this at least.
Yeah, it looks simple enough.
Good. It's deceiving though. It looks simple, but it'll get a little more complicated, of course. But yeah, this is about the gist of it. So like I've been saying, we'll say, hey, here's some various here's like a scenario. Can you program, around that scenario? And we'll take real world examples too. So I'm not going to take goofy things like you might do in some other programming classes. We'll do real world industrial examples, and just have you a chance to test it out. And don't worry about if you didn't get the program right or not. This is not one of those classes where we're gonna, fail you if you didn't get it. We just really want you to kind of just get in the, get comfortable writing in this, this language, and get comfortable just kind of working with the PLC software, because it will, it is very well could be something you do in your job once you graduate and start working. So So it's not really here to intimidate you. It's just to get you to be start to kind of at least get some experience with it. All right. So that's about it. I know it's been a long day, but unless you got any other questions, just look for some stuff. I'll probably try to post something. Hopefully the next couple of days, I'll try to do some better videos of what I was trying to, some live demonstrations of what I was talking about here tonight. And that will help you hopefully visualize this a little bit better. And just let me know if you have issues still with getting the software installed. We'll try to figure out what's going on there. All right. So that's about all I got. If that's all you have. I'll stop sharing. All right. Everybody have a good night.
You too.
All right, guys. All right.